Kole ngambulo luku with whatever we do. Hale yide munyu skula nyepamne ne kudlukula nyepangiragala gena nyepamne ne kudlukula ibuloke numoto ni beti sola ibuloke dato ni betoto
Bengi Kongo
Lamin
na
Rinte nyamen Lamin
Kamana
wulo kono nyinta mo Lamin
Pabilenki
muna ngata afamole
haina
ngata ngoto le dama
Bengi Baba nyole
no ngoto le faburama
namu jumala kan kuma diten
faburama
jumala mu
ndele bare muso
ni bere
alindo ko
jamani
bari ngoto man kontande
na mu do kontan
ngoto minaka ngalamin de fom filitala lamin jibe nori nyaala
lamin ila siran sama ne benki yala so tol sayni no ko ngol ko momo
ngoto nte yalo ne lamin hakilo dia anu santeng ministry ko di ngole si suwo ko amake ko be holiday la
sibitun
ko de namo balo ba
ane na ko la nije
ngoto
nam
ngoto man kontan feren
jamani mu nekata
ifika lamin ki wulo ko no nyintay mon ko do fete malo lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karambugol man soron ni ko karambugol soron da amake comme holiday la ngoto dindi ngo nyanta sila la ala karango la moy yamen kamen fue man kontan andamande
alla nyin kombo courant jan karamol le sorande do kamen kombo e gondol fana na karamol sorande karamol sorande no so kon ala mu nekela
am lamin ite fay de kar
e ko nyani mo lamin ya mu na fonye
bir kabin mina kan tambita nteri maning fatu
ha
tambite la sugal ala dinngol bebe siri be la moy ka
faru danso am fana tambita je dinngol be je talanta nen kili warol e be seri jelet
sa lamin fanante ku kili woke no la ba lamin bi taymo alamin ite ya kari lesuno la moy radio to balon na
mu ne ka ke afonye ba nyara ni alon
telentel jikot
afonye ba mu ne be ke
ite balon tel be cikiritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
par nyarande kombo courant ho findira kombo ite na raje ni sonka bay ko lamin manya tala wulo ko karamol be so afonye membe
ko to wole nati ba ngalle ni lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men da karamo
ila subjector baby jele
wala nanga dan so wala ngombe tambi kana ngadi ngol jebe ikadum bungo ko kada mala mo
asototal de
lamin mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko ma ko nde ko folle sinila ba ndele sinilo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat yim fadam bulata ko ko don meyen nati jambi lamin nyan jiko be nyine ka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje en koto dindi ngoy si ayala le sino la moy radio
wada ka munda kara mo man soro lamin nyanda kara si so na radio
la sila le ayala le sino
ndale ko korna ko smalo
kilar ya
mo be ngala ko momo say mi do ni ko no kera
mengi bruce
ndale ko radio la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra ko man dembe guljan dala nyara nyar wo ko fendi mo la lamin tayra ba rosa
be nori nya
teku ja image nañu ñambol si se ole ke je kisigi man si se ol no le kafun ka ñowa bari ñambu kino ni manya na ka finde ni nambe ko so la ga
ngalle limbeta de be ñambo do dilanna
ñara ni ko ridin fennat ñara nata
ko bari faamo kada
ngata bun kono tabi bun kono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awa betar la
bun kono bismillah bisu diara
ye fongo tanka sina do lutanka koro ta koro
Hi everyone, I am Mr. Babukar Au, your chemistry tutor, and today our lesson of discussion will be based on the forces of attraction. Now we are discussing about the types of intermolecular forces. In this lesson, we discussed about hydrogen bond. So we will just do a short recap on hydrogen bond. Now we said hydrogen bond will in what? Atom with any of these atoms that is formed. And then last time we said this F is for what? Fluorine, and this is for oxygen, and this is for what? That is hydrogen bonds and also van der Waals forces of attraction. Now van der Waals forces of attraction also, we have types, but there are certain molecules that are van der Waals, and these molecules, there is what? Slight polarity, because there is what? Partially negative charge and also partially positive charge in these molecules. We also have other molecules that exhibit these van der Waals forces of attraction, and then the atoms will be what? From the same element. Therefore, they must have the same charge. But due to electron density, there will be also what? Slight what? Attraction. But in this case, the attraction is just going to be what? Temporary. Now, the definition of van der Waals forces of attraction reads, these are weak forces of attraction induced by interaction of what? Dipole moments between atoms or non-polar molecules. Yes, between what? Dipole moments. We have dipole moments and also between atoms or non-polar molecules. Now, that dipole moments is where we'll have what? Opposite what? Charges. And then these opposite charges, we will have partially positive and partially what? Negative. Or we have the non-polar molecules. And these non-polar molecules is where we'll have what? Atom of the same element. And in this case, due to electron density, there will be what? Attraction. Now note, dipole moment is the product of the charge on a dipole and the distance between what? The charges. For instance, if you have a molecule and maybe the molecule is HCl, now the difference between these charges, that is the distance, because we know HCl, there is hydrogen and also there is what? Chlorine. So different that are what? Opposite, positive and what? Negative. And also the distance, if you combine these two, is what we mean by this dipole moment. Now, we have again to denote, they are the weakest forces of attraction between what? Molecules. Now, because we said intermolecular is the bond that takes place in every. Now, hydrogen bonds are the what? Are this what? Intermolecular. And also we have what? Van der Waals forces of attraction. And these are the what? Weakest forms. And this is what? The strongest bond that can exhibit between what? Molecules. Weakest. Now, they increase in importance as the number of electrons in the atoms and molecules increase. That is, for instance, if you have something like Cl2 and also what? I2, you can determine which of them is stronger by looking at the what? We'll know that this one will be stronger, has what? More electron than the chlorine gas. So therefore, this I2 will be stronger than what? Cl2. Now, they occur between all molecules and are therefore important in 1. Liquefaction of gases like hydrogen and also helium. Now, because of the existence of intermolecular force between these kind of molecules is why you can liquefy gases like hydrogen and also liquid. You can convert them from gas to what? Liquid. And also formation of molecular lattice as in iodine and naphthalene crystals. That is, iodine can exist in the form of solid at room temperature and also the same thing as naphthalene. And all these things is because of what? The existence of intermolecular forces between molecules of these substances. Now you have factors affecting van der Waals forces. Factors affecting van der Waals forces. What are the factors that influence the formation of van der Waals forces in these kind of molecules we are talking of? Now, 1, electronegativity difference and also polarity. Electronegativity difference and also polarity. That is the first factor. We said is what? Electronegativity and also polarity. Electronegativity difference and also polarity. Now, the greater difference between the two atoms in a molecule, the more polar the molecule and the stronger the van der Waals forces of attraction. That is, if you have HCl and also you have H2S. We have hydrogen, hydrogen. Here we have chlorine, and here also we have what? Sulfur. Now, the electronegative value of chlorine is higher than what? The electronegative value of what? Sulfur. So therefore, the difference between, you will have a greater difference between the hydrogen and the chlorine than chlorine and what? This sulfur. Therefore, you can say that stronger than what? H2S. Because of what? Difference in what? Electronegativity. You must consider the difference between the sulfur and the hydrogen. The difference between what? Chlorine and also this hydrogen. That is, the larger the distance between the two combining atoms, the more polar it becomes. And then when it is polar, therefore, the van der Waals force there will be stronger. But remember here, we are talking of what? In molecular bonds. 2. The size of atoms and also number of electrons. Size of atoms and also number. Now, number 2, we have size of atom and number of electrons. That is, the bigger the molecule, the larger the number of electrons in it, the more easily polarized and the stronger the van der Waals forces. Here you are considering two molecules with different sizes and also with different number of electrons, because we know that larger molecules tend to have what? More electrons. So the more electrons contained in these molecules, the more significant the bond contained in them become. And then the easily polarized and also the stronger the van der Waals forces. Therefore, small molecules will have what? Small number of what? Electrons. Therefore, their van der Waals forces becomes weak. And number 3, we have molar mass. The higher the molar mass, the stronger the van der Waals forces. For example, the strength of van der Waals forces increase in what? Molar mass, as shown in, that is, methane, HCl, and also chlorine gas. We have, that is 3. We can have CH4. We can also have HCl, and also we can have what? Chlorine. Now here, the molar mass of methane can be calculated. The relative atomic masses of these elements. And the relative atomic mass of carbon is 12. We add it to the relative atomic mass of hydrogen, which is 1, but multiplied by this 4, we have what? 4. 12 plus 4, we have 16. And here we have what? 1 for the hydrogen plus 35.5 for the what? Chlorine. And then here we will have 36. Chlorine here also is what? 35.5. But we have 2 atoms of chlorine. We multiply by what? By 2. And then at the end we have what? 71. Now you see, there is higher molar mass in chlorine than in what? HCl. There is higher molar mass in what? HCl than in what? Methane. Therefore, chlorine will be stronger than what? HCl. HCl also will be stronger than what? Than methane. We can say something like this. Methane is less than what? HCl. And again, HCl also is less than what? Chlorine gas. Now we have van der Waals forces of attraction. Now, the first type we have is called dipole-dipole forces. Now, a dipole is a pair of equal and separate opposite electric charges. The molecules are called dipolar molecules. Now we have a model on the screen, and then you see that the model, we have 2 different atoms. in the same molecule, bonding with another molecule, and the molecule also contains atoms. And then it is separated by using colors. Now check, where we have the negative charge, and it is partially negative, and the other color, which is blue, is partially what? Positive. And in the other molecule also, we have partially negative and also partially positive. So there will be what? Attraction between the opposite charges in the different molecules. That is, the slight positive charge in one molecule will try to cause attraction with what? The slight negative charge in the other one molecules. And these kind of molecules now are called dipolar molecules. Now, dipole-dipole forces are attraction between partially positive end and one dipole and the partially negative end of a nearby what? Dipole. Now, dipole-dipole forces must occur between dipolar what? Molecules. A partially positive end of one dipolar molecule will tend to attract the other dipolar molecule of a nearby what? Dipole. But then it will attract the partially negative end, so that there will be what? Attraction. There will be what? Force. And this force will lead to the formation of a bond. Now, these forces occur in what? HCl gas, H2S gas, SO2 gas, etc. and etc. That is where you have HCl. You see, this HCl now, in the form of what? Gas, is van der Waals force. And then it is what? Dipole, because this hydrogen now, the partially positive end and the what? The partially what? Negative end. So this can easily bond with an other molecule of what? HCl, where this one also will be what? Partially positive end, and here we'll have partially negative attraction, negative end. And this same attraction can take place with another what? Dipolar molecule like HCl. And the same thing can happen in H2S, the same thing in SO2. Now, dipolar molecules are soluble in water through hydrogen bonding and dipole-dipole attraction. That is, these above molecules can dissolve in what? In water, because water is hydrogen bond. So the water can easily hydrogen bond with these above molecules, or it can what? Dipole-dipole what? Attraction. There could be dipole-dipole attraction between the water and also these above molecules. Therefore, the molecules will be soluble in water. The second type of van der Waals force we have is called induced dipole or induced dipole forces. That is induced dipole forces. And the other name is called the London dispersion forces. London dispersion forces. Now, these occur between non-polar covalent molecules. In these molecules, there must be what? Covalent bonds. There must be covalent bonds inside. That is, the intra-bond must be covalent, but then the interbond must be what? London dispersion. Now, they are purely what? Non-polar. There is no what? Partially positive or partially negative before the starting of this kind of bonds. Now, this force is a temporary attraction force that results when electrons in two adjacent atoms occupy positions. Atoms form temporarily what? Dipoles. Now, in the case where you have something like chlorine gas, we have two atoms of what? Chlorine. Two atoms of chlorine. And this is the what? Interbond. Intrabond, which is the what? Covalent bond between one atom of chlorine and another atom of chlorine. But then if this chlorine need to bond with another what? Atoms of what? Atoms of chlorine, which is going to be chlorine. Now this bond now is what is termed as London dispersion force. See, they are atoms of the same element. You can have your Cl, 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 Cl. Now, but because of what? Electron density, that is one of these chlorine now will tend to what? Possess what? The electrons, and therefore there will be what? Temporarily what? Attraction. There will be temporary dipoles in this molecules. Now you can have here something like partially positive and what? Partially what? Negative, depending on the side on which the electrons falls. And then also the same thing can, and then at the end you will have what? Attraction. But these attractions are just what? Temporary, because these atoms are not known to be what? Positively what? Charged. Now we have a model that shows the London dispersion force. You see, in the first molecule, where you have partially positive and partially what? Negative, the electrons falls to the side of the what? To the edge of the molecule, where you have the partially what? Negative. And the other side, where you have less electrons, is where you have the partially what? Positive. The same thing applies on the other what? Side of the molecule. The side you have the electrons is where you have the partially negative, and the other side in which you have the less electrons is where you have the partially what? Positive. So there will be what? Temporary attraction between the what? Partially positive from the first molecule to the partially negative in the what? In the second molecule. And then we will have what? A bond. But this bond now will not be strong as the what? Dipole-dipole bonds, because this one is just what? Temporal. Now these forces occurs in hydrogen gas, in iodine molecule, in CO2, and also in inert gases, etc. Now CO2 is somehow different with the other molecules, because CO2, that is carbon dioxide or carbon dioxide, tend to contain what? Polar bonds. That is, we have CO2. Now you see, we'll have what? One atom of carbon, one atom of oxygen, and another atom of oxygen. Now at the end, we'll have here 1, 2, 3, 4. That is, the carbon will bring 2 electrons, and oxygen also will bring what? 2 electrons. Now this oxygen will be left with 1, 2, 3, 4. Here also we'll have what? 1, 2, 3, 4. 2 from the what? Carbon, and also another 2 from the what? Oxygen. At the end, the oxygen will be left with what? With 4 electrons. Now you see, the electronegativity value of this atom is equal to this atom, because this is oxygen, this is also what? Oxygen. So the strength of this atom is equal to the strength of this atom. The way this oxygen is pulling this carbon is the same way that this other oxygen is what? Is pulling what? The other what? Atom. And there are what? No lone pair of what? Of electrons on the what? On the carbon atom. Therefore, this becomes what? Non-polar. Even though it seems to contain what? Polar. The molecule it says what? Polar, because the polarity will cancel by what? These two oxygens. Now we have some trial questions. Now, and the first question there reads, which one of the following derivatives of methane, that is CH4, has the highest boiling point? Which of the following derivatives of methane has the highest boiling point? A, we have tetrabromomethane, that is CBr4, and B, we have tetrafluoromethane, that is CF4, and C, we have tetrachloromethane, which is CCl4, and D, we have tetraiodomethane, which is CI4. Now the one which is, the one which will have the highest boiling point will be the one with the highest molar mass. And then if you consider A, B, C, and D, you know that D will be stronger because it's where you have what? Iodine. Because all the other molecules are having carbon, 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 carbon. And then the other atoms in A is bromine, the other atom in B is fluorine, the other atom in C is chlorine, and then D we have iodine. And iodine has what? Higher relative atomic mass than the rest. So therefore, D will be the what? The correct option. Now, number 8, we have which one of the following derivatives of methane has the lowest boiling points? A, we have CBr4, which is tetrabromomethane, and B, we have tetrafluoromethane, which is CF4, and C, we have CCl4, which is tetrachloromethane, and D, we have tetraiodomethane, which is CI4. Now, the one which has the lowest boiling point in this question is letter B, which is CF4, because fluorine there is the smallest atom in all the options. So the correct option there will be letter B, which is CF4. Now we have our assignment question, that is the assessment. Now we will try this question at home, and then in our next lesson we will try and answer it together. As number 1 reads, use the information provided in the table below to answer the questions that follow. That is, we have a table, and the first column we have element, and the second we have atomic number. And the elements are P, Q, R, S. And P has an atomic number of 19, Q is 18, R is 17, and S is 8. Now, letter A, what type of bond exists between P and R in the compound PR? B, write the formula of the compound form when P combines with what? S. When P combines with S. C, what type of bond exists between atoms of S in each diatomic molecule? What type of bond exists between atoms of S in each diatomic molecule? D, state with reason whether or not a bond will be formed between two atoms of Q. State with reason whether or not a bond will be formed between two atoms of Q. E, which of these elements is a metal? Which of these elements is a metal? And finally, F, which of the elements is a halogen? Now we move to question 2. Now 2A reads, name the types of bonds present in the oxonium ion. Name the types of bonds present in the oxonium ion. Letter B, give one effect of the existence of intermolecular hydrogen bonding on the physical properties of ethanol, that is C2H5OH. Give one effect of the existence of the intermolecular hydrogen bonding on the physical properties of ethanol, that is C2H5OH. Now, let's try and answer these two questions. And as I said, in our next lesson, we will try and answer these questions too. So, with this, we come to the end of this lesson. Stay tuned for more chemistry videos. Thank you all.